Hello students, welcome to today's lesson. So in the third lesson of your science textbook, we have discussed the nature and properties of matter. So we discussed how we can classify matter as pure substances and mixtures. Then under pure substances, we discussed elements and compounds, as well as you all know how to give or write symbols for elements as well as compounds. And you all have an understanding about the way compounds form. That is, by the chemical combination of atoms of elements form the molecules which make up the compounds. And under molecules, we have discussed what homoatomic molecules and heteroatomic molecules are. And thereafter, we discuss the mixtures and the two types of mixtures, homogeneous mixtures and heterogeneous mixtures. Then we also discussed how we can separate the components from the constituents from the mixtures, the physical separation methods. So now I am going to discuss some questions with you all, and I am going to start off with the questions given in your textbook. So I am sure you have already answered these questions. If not, answer it first and then listen to my discussion. So the first question, you all can see, select the correct or more suitable answer. So you're familiar with these type of questions. These are the MCQ types, multiple choice question. Why do they say correct or more suitable? Correct, there will be just one correct answer. But when they say more suitable, there can be two answers which seem correct. But out of the two, you have to select the more suitable one. So let's look at the questions. The number of protons, neutrons and electrons in the 3517 chlorine atom respectively are. So in this, students, you all know this is the standard symbol of an atom, and there what is written on top, that is the mass number. That is equal to what? The number of protons and neutrons. Whereas the one at the bottom is the atomic number. That is equal to the number of protons. And in an atom, because it is electrically neutral, the number of protons equals number of neutrons. So that is something that you can identify. So here you all know we can do the calculation, students. Atomic number is that is equal to number of protons, and that is in turn equal to number of electrons. So you all know that is given as 17 there. So number of protons and number of electrons equals 17. Then what is mass number? Mass number A, you all can remember the symbols also, is equal to number of protons plus number of neutrons. So what is mass number? They are 35. That is equal to proton 17 plus neutrons. So if you find the number of neutrons, 35 minus 17, you will get the value as 18. So that is how you calculate the number of subatomic particles. So students, then the second one, of the following statements given about the atoms, select the false statement. So here you have to select the false statement. So that should not be correct. If we look at the first one, atoms are the building units of matter. That is correct, because you all know all matter is made up of atoms, whether in the form of elements that are made up of atoms, or homoatomic molecules or heteroatomic molecules, but they are also made up of atoms. So the first statement is correct. Then the second one, a large portion of an atom is empty space. You all can remember the structure of atoms, students. Who proposed the structure of atoms? Ernest Rutherford. According to his structure, you all know the major part of the atom is empty space because the nucleus is a very tiny part. Then the third one, there is a positively charged nucleus at the center of an atom. That is also correct. Why? Because nucleus contains the protons and neutrons, and protons are positively charged, whereas the neutrons are without a charge. So the nucleus becomes positively charged. Then the fourth one, an atom cannot be further divided. Think of this statement. Now, can we divide the atoms? There are subatomic particles. You can divide the atoms, but if you divide it, you will not get another substance with definite properties. The subatomic particles don't show a certain property. For example, you all know if we take sodium, that has certain properties. But if you break the sodium atoms into electrons, protons and neutrons, there is no specific property. So that means this statement is false. An atom cannot be further divided is wrong. So the first three statements are correct. The last statement is false. Can you all understand that? Because when we defined atoms, we said they cannot be further divided into other components that can exist independently in nature and that have specific properties. That is not possible. But the atom is made up of subatomic particles. So therefore, we can divide it. So therefore, we can say an atom cannot be further divided is a false statement. So I am sure you were also able to get these two answers. With that, students, I will move on to the next question. Question number 3. A unique property for a certain atom is. Now, for an atom, there is the atomic number, the mass number and the symbol. Out of these, what is the property that we say as unique property? That is the atomic number, that is equal to the number of protons present in the nucleus. So that is the unique property. So it's atomic number. That is correct. The number of neutrons in the nucleus, that of course can vary, or it can be similar to more than one atoms as well. Its mass number, that is also not a unique property. Then the sum of the number of neutrons and protons. Again, the sum of the number of neutrons and protons is the mass number. And sometimes, students, we have not discussed that now, but you will learn that later. Sum of the atoms of the same element can have different mass numbers as well. But you have learned that the unique property is the atomic number. So for this, it is the first answer. It's atomic number. A unique property for a certain atom is its atomic number. Then the fourth one. Which of the following contains matter belonging to the same set? So you have to find the matter that belongs to the same set. So what are the types you all know? You all know about elements, compounds and mixtures, undermixtures, homogeneous mixtures and heterogeneous mixtures. So if we look at the first one, now sodium is an element, carbon element and oxygen element. So in this, all three are elements. So that means these are matter belonging to the same set. But we will check the other answers as well. In the second one, oxygen is an element, water is a compound and air is a mixture, that you all know. Air has many gases, water vapor, everything present in it. So it's a mixture. Then the third one, water again is a compound, carbon and sodium, they are elements. So that is also from different types of matter. Then fourth one again, air mixture, carbon and oxygen elements. So that means which of the following contains matter belonging to the same set? It has to be sodium, carbon and oxygen, they are all elements. Is that okay, students? So then we will move on to the next question, question number 5. Of the following statements given about the element nitrogen, select the false statement. So here again you have to consider the element nitrogen and it has to be the false statement. So let's look at the statement. Nitrogen is a pure substance. Is that correct? Yes. It is an element. It exists as homoatomic molecules, N2 gas. It is a pure substance. So that is a true or correct statement. Then nitrogen molecules are the building units of nitrogen. What can you say about that? Nitrogen molecules, because nitrogen gas exists in the form of nitrogen molecules. So that statement is also correct. Then the third one. Second one is also correct. Then the third statement, nitrogen molecule is formed by the combination of a large number of nitrogen atoms. Is that correct? This part, the large number of nitrogen atoms, is not correct. Why? It is only made up of 2 nitrogen atoms. N2 molecules. You all can remember that. We have written the chemical formula, N2 molecules. Then the fourth one, nitrogen is a constituent of air. That you all know. There is 78% of nitrogen in atmospheric air. So that is also correct. So that means the false statement given about the element nitrogen is that nitrogen molecule is formed by the combination of a large number of nitrogen atoms. So it is this answer that is false. Is that correct, student? I am sure you also selected the same answer. Then the last one. Of the following substances given, the pure substance is. So when they say pure substance, it can be an element or a compound. Air is a mixture. There are many gases. Then salt solution. So that means salt is dissolved in water. So those are all mixtures. Now this is a mixture. Salt solution is a mixture. What about vinegar? Vinegar is acetic acid. So you all know that is a compound. Then it has to be a pure substance. But still, when we say vinegar, the vinegar that we buy from the shops or what we use for cooking purposes, it will contain acetic acid, but there can be other components as well. So, of the following substances given, the pure substance is. Then if we look at the fourth one, copper sulfate, that is more suitable because copper sulfate is just one compound. Now here instead of vinegar, if they have said acetic acid, then of course that will be a compound, so it is a pure substance. But the vinegar that we buy, sometimes you might have heard about apple cider vinegar. So there is an essence, there is a certain flavor or what it was made from. So because of that, the vinegar can contain other components as well. So it will become a mixture. So out of these, of the following substances given, the pure substance is copper sulfate. Is that correct, students? So then with that, I will move on to the next question. This is a table. Fill in the blanks considering proton and neutron amounts of particular elements. So you have to consider the proton and neutron amounts. The first one, the first column, you can see the element is given to you all. In the second column, they have given the number of protons, third one number of neutrons. Then you have to find the atomic number and the mass number. But you can see randomly it has been filled. So if we take the first element, sodium, the number of protons is 11. So from that, what can you write? You can write the atomic number. So it's easy. Number of protons equals atomic number 11. Then they have given you the mass number. Now, if you know the number of protons and mass number, I have already told you all, is at this atomic number that is equal to number of protons, that is again equal to number of electrons. And mass number A, that is equal to number of protons plus neutrons. So, you all know that. So, if you know the number of protons, you can substitute the value here, that is the atomic number. What can you do? Instead of number of protons, we can also write the value of atomic number. So, atomic number plus neutron. So, that means mass number minus atomic number will give you the number of neutron. Is that okay, students? Can you all understand that? Mass number is protons plus neutrons. Atomic number is protons. So, here since they have given you the number of protons and mass number, or in some instances they have given you the atomic number, we have found another way of calculating the number of neutrons. You can use any one of these equations that are necessary to find the number of particles. So here, to find the number of neutrons, you can use either one of these methods. Number of protons 11 and the mass number 23. So if you subtract from 23, if you subtract 11, you will get the value as 12. So there are 12 neutrons. Then the second one, calcium. We don't know the number of protons, number of neutrons and atomic number are given. Atomic number is equal to number of protons. So we can write it as 20. Then number of protons and neutrons are equal to 20. Both are equal and it's equal to 20. So we can easily find the mass number. How do we find it? 20 plus 20. So here it is going to be 20 plus 20. So the value is 40. Is that okay, students? So then, iron, we have iron here. We don't have the number of protons or number of neutrons, but we have the atomic number there. So from atomic number, what can you find? Atomic number equals number of protons. So we can write the protons as 26. Then what do we have? We have 56 mass number. Now I have given you this equation. Mass number minus atomic number. So here it's going to be 56 minus 26. So what is the value? It has to be 30. Number of neutrons is 30. Is that clear to you all, students? So then you can find for sulfur, the next element. Again, the number of protons is not given, but you have the atomic number, that is 16. So that means number of protons equals 16. Then you have the number of neutrons. We don't have the mass number. There you all know it's a direct calculation. You have to add the two values. Number of protons plus number of neutrons gives you mass number. So here 16 plus 16. That is going to be 32. Is that okay, students? So then bromine. Number of protons is given as 35. Number of neutrons and atomic number are not there. So number of protons equals atomic number, that is 35. Then we have mass number. Mass number you know is equal to number of protons and number of neutrons. So number of protons we know is 35. So what do you need to do? Mass number minus number of protons, 35. So what is the value there? It has to be 45. Is that okay, students? So you all can find all these values. So when you are given two values, you can find the other two values. Out of number of protons, number of neutrons, atomic number and mass number. Even if you are asked to write the number of electrons, that also you can do. How? Number of protons in an atom equals the number of electrons. So is that clear to you all, students? We have found all the values. For sodium, number of neutrons 12, atomic number 11. Then calcium, number of protons 20, mass number 40. Iron, number of protons 26, number of neutrons 30. And sulfur, number of protons 16 and the mass number 32. Then bromine, we have found the number of neutrons as 45 and the atomic number 35. I am sure you have filled the table correctly. So with that, I will move on to the next question. Indicate whether the mixtures given below are homogeneous or heterogeneous. So you have to identify them. The first one, tea. What is this? Is it homogeneous or heterogeneous? I have told you all, students, normally tea we filter and take. So once we filter, whether it's plain tea, milk tea, doesn't matter, the composition is uniform. So that is a homogeneous mixture. Homogeneous mixture. Then the second one, sea sand. What can you say about sea sand? There will be sand, but there can be other particles also present in sea sand. You don't get only the sand. So, most likely it will be a heterogeneous mixture. Sea sand, heterogeneous mixture. Then the third one. What is that? Rice mixed with chaff. It's very easy to identify. You know the rice, those are solid grain particles. Chaff is the outer covering, very light component. So, easily you know it is a heterogeneous mixture. Why? The uniformity is not there. Composition is different. So, that is a heterogeneous mixture. A heterogeneous mixture. Then we have the fourth one. Now, fourth one, vinegar. Now, you all can remember, students, before also I told you all vinegar, there will be other components as well. So, because of that, it is a mixture. But there in the mixture, you cannot see any other components separately. And also, the composition is uniform throughout the mixture. So, that means this is going to be a homogeneous mixture. Homogeneous mixture. Then we have the last one, that is the fifth one, copper sulfate solution. Fifth one, copper sulfate solution. What is copper sulfate solution? You have seen this in the lab. It is a blue color crystalline solid. When you dissolve it in water, you get a clear blue color solution where the color, density, everything is uniform throughout the solution. So, that means that is a homogeneous mixture. So, copper sulfate is a homogeneous mixture. Homogeneous mixture. So, is that okay, students? We have classified all the mixtures. Tea is homogeneous mixture. Sea sand, heterogeneous mixture. Rice mixed with chaff, heterogeneous mixture. Then vinegar, homogeneous mixture. And copper sulfate solution, again homogeneous mixture. So, did you all get everything correctly? I am sure you did. With that, I will move on to the next slide. So, here we have the fourth question. Copy the following figure on classification of matter in your book and fill in the blanks. So, you have to fill the blanks. You all know matter is mainly divided as pure substances and mixtures. So, here it has to be pure substances. And under pure substances, what do you have? Elements and compounds. So, compounds are given to you. This has to be elements. Elements and compounds. Then under mixtures, what are the two types? The homogeneous mixture and the heterogeneous mixture. So, we have the homogeneous mixture and heterogeneous mixture. So, students, when you are copying this table in your book and when you fill in, you can nicely write it within the space given to you. But here, I have written it out of the box also, but you all know homogeneous mixture and heterogeneous mixture. That is under mixtures. And under matter, the other one is the pure substance, under that elements and compound. So, this is the basis of this particular chapter. So, you all know that very well. With that, I will move on to the next question. Give short answers. That is your fifth question. The first one under that is name 3 pure elements and 3 pure compounds. Second one, write the formulae of 3 compounds which you know and name the elements in them. Then the third one, write the chemical symbols and names of 5 elements symbolized by a single letter. Just one letter to symbolize the element. And the fourth one, write the chemical symbols and names of 5 elements symbolized by 2 letters. So that is the fourth question. So then we will move on to the first one. Name 3 pure elements and 3 pure compounds. So pure elements, you all know many elements. So let's say I will write as pure elements. Then what are the pure elements you all know? You know about carbon. Then you know nitrogen. What else do you all know? You know many other elements. Iron, sodium, calcium, hydrogen, oxygen, all those are different types of elements. So those are pure elements. We can write any carbon, nitrogen, then I will say calcium. Calcium. Then we need to write 3 pure compounds. So that again you can write pure compounds. What can you write? Pure compounds. You are familiar with some compounds. Carbon dioxide is a compound. Let's say carbon dioxide. Then what else? Copper sulfate is another compound. So we can write copper sulfate. Then what about water? Water is a compound, but not the tap water, not the drinking water, not even seawater, because they are all mixtures. They have many other substances dissolved in them. So what should you write? You have to write as distilled water, or you have to say pure water. So here I will write it as distilled water. Distilled water is pure water. So they have asked for 3 pure compounds. So as 3 pure elements, we have written carbon, nitrogen and calcium. You can write any other element that you wish. Even gold, silver, aluminium, sulfur, all what we have learned. Then pure compounds, carbon dioxide, copper sulfate, distilled water. You can also write ammonia, then you can write methane, any one of those compounds as well. Sodium chloride, hydrogen chloride, those are all pure compounds. Then the next one. Write the formulae of 3 compounds which you know and name the elements in them. So the compounds which you know. Shall we take glucose? That you all know. So and we have learned the chemical formulae as well. Glucose. What is the chemical formula of glucose? It is C6H12O6. So then what are the elements present? There is carbon, hydrogen and oxygen. Is that okay, students? Carbon, hydrogen and oxygen. So that is glucose C6H12O6. What are the other compounds you all know? What about ammonia? You all know the chemical formula of ammonia. So then we have the second compound, ammonia. What is the chemical formula of ammonia? NH3. We have written the structure as well. So what are the elements present? It is nitrogen, N is nitrogen. and H is hydrogen and hydrogen. Then we have, let's say we can take copper sulfate. Copper sulfate or sodium chloride. I will take sodium chloride, common salt. Sodium chloride. What is the chemical formula? NaCl. So there are sodium and chlorine, sodium chloride. So this gives rise to the elements sodium and chlorine. So sodium chloride. You all are familiar with many other compounds. We have discussed ethene, acetic acid. Like that, we have discussed so many other compounds. Methane, and you all know the chemical formula. Even copper sulfate I mentioned before, CuSO4. So there's copper, sulfur and oxygen. So like that, you can write any of the compounds that you all know. Is that okay, students? So you should write the name of the compound, write the chemical formula and the elements that make up that compound. You can write it in words or else you can use the symbols also. So in case you like to write it as symbols, that is very easy, no? You have the chemical formula here. You will be writing it as carbon, hydrogen, oxygen. Then this one, it is only nitrogen and hydrogen. Then sodium chloride, it is sodium and chlorine. So it's easy to write the symbols as well. So here they have said write the formulae of 3 compounds which you know and name the elements in them. So because they have said name the elements, it's better to write the names without giving the symbols in it. Is that okay, students? So with that, I will move on to the next question. Write the chemical symbols and names of 5 elements symbolized by a single letter. So it has to be just one letter. Can you all think of 5 elements? Hydrogen, it is just H. So hydrogen, we can say hydrogen. Then what about carbon? Carbon, C. Carbon. Then we can take sulfur, S. Sulfur. What else can you think of? Just one letter. What about nitrogen? Nitrogen, N. So we have taken hydrogen, carbon, sulfur, nitrogen, even oxygen is one letter. O, oxygen. Fluorine, that is one letter, capital F. So like that, you can write the chemical symbols and names of 5 elements symbolized by a single letter. Is this okay, students? Hydrogen is C carbon, S sulfur, N nitrogen and O oxygen. Then the next one. Write the chemical symbols and names of 5 elements symbolized by 2 letters. So it has to be 2 letters. What can you write? You can write this symbol. What is this? Argon. This is argon. Then what is this? Cu. We have discussed that. Copper or cuprum. Cuprum is the Latin name. Copper is the English name. Here they have said write the chemical symbols and names of 5 elements. So what you have learned before, I'll write both the names. So this is cuprum or copper. You all can just write one name. That is fine. The same way, Na. What is this? Natrium. Natrium or sodium. Then we have Ca. What is this? Calcium. Then one more. We need to write 5 elements. Ar is argon, Cu cuprum or copper, sodium that is Na, natrium or sodium. Then I have written calcium, Ca. What else can you write? You can write Cl, chlorine. Cl, chlorine. So these are all elements that have symbols with 2 letters or indicated by 2 letters. You can even write iron, Fe, gold, Au, silver, Ag. Like that, you can write any other symbols as well. So, is this clear to you all students? We have learned all these symbols to write their chemical symbol and the name. And you are familiar with the Latin name as well as the English name. So, with that, we have finished the questions given in your textbook. So, now I will be discussing some extra questions. So, extra question 1. Complete the diagram given below. Again, here you can see it is how matter is classified. So, matter, this side is pure substance. So, what is that? It has to be the mixture. Earlier, we used the term non-pure substances, but now you have learned the term mixture, so we call it as mixtures. Pure substances and mixtures. Then under pure substances, what do we have? We have elements and compounds. Elements and compounds. So under elements, what are the examples you can write? Or before I go for that, then here you can see example is given as salt solution. So you know salt solution is a homogeneous mixture. So this will be a homogeneous mixture. Then what is this? It is a heterogeneous mixture. Then we will write the examples. So for elements, what can you write? Any element. Oxygen. Then what else can we write? Gold, aluminium. I have written 3 examples. You can write any example there as an element, example for element. Then we have compounds. Again, we have discussed many compounds. Let's say methane, that is a compound. Then there is hydrogen chloride. Hydrogen chloride. So this is one, this is another one. Like that, you can write any other compound. Even glucose, that is a compound. Copper sulfate is a compound. Like that, you can write any example there. So we have written examples for elements, then for compounds. And here for homogeneous mixture, there is one example given to you, salt solution. Like that, you can take the example sugar solution. So here you can have sugar solution. Even copper sulfate solution. All these are homogeneous mixtures. So salt solution, sugar solution and copper sulfate solution, they are all homogeneous mixture solution. Then here we have the heterogeneous mixtures. What can you think for heterogeneous mixtures? You can write fruit salad. Then what else? We can write rice and chaff mixture. Rice and chaff. Then we can even write the soil. What you get? That is also a heterogeneous mixture. Soil. So these are all different types of heterogeneous mixtures. Is that okay, students? So although they have asked to write just one example, here you can see they have given only one example, salt solution. I have written more than one. I have actually written 3 each, and I have given some more examples. So you can write any example that you like. So I am sure you were able to fill this table or this chart correctly. That is the classification of matter. So with that, I will move on to the extra question 2. What are elements? What are elements, students? Those are the pure substances that have a specific property and they cannot be divided further into simpler substances with different properties by either physical or chemical methods. Then they are known as elements. So that is what you have to write here. Pure substances with specific properties that cannot be further divided by physical or chemical methods into simpler substances with different properties are known as elements. So we can stop the answer there or complete it by saying are known as elements. So pure substances with specific properties that cannot be further divided by physical or chemical methods into simpler substances with different properties are known as elements. Is that okay, students? So that is the answer for this question. Then we have the second question. Write 2 uses of symbols of elements. What are the uses of symbols of elements? We use the standard symbols to denote the elements. So in that we have the atomic number, mass number, and also when we are learning about elements, it is easy to use the symbols. That is one use. Then there is the other use. We have written symbols for compounds. In that, what did we use? We use the symbols of elements to denote the symbol of compounds. So for that also we can use the symbols of elements. So 2 uses. One thing, can use symbols easily when learning about elements. Then the second one, symbols of elements. Elements are used to write the symbols for symbols or formulae. We called it chemical formulae for compounds. Is that okay, students? So write 2 uses of symbols of elements. We can use symbols easily when learning about elements. Because when writing carbon, copper, sulfur, it's easier to use just one letter or 2 letters the most. So that's more easier. Then symbols of elements are used to write the symbols or formulae for compounds. That is another application. Then we have the third question. Write an advantage of using the symbols of elements. What is the advantage? Now these symbols are standard symbols and they are accepted internationally. So therefore, wherever you go, you know what element they are referring to. So that is an advantage of using the symbols of elements. So here we can say the symbols of elements are internationally used. Therefore, irrespective of the country or language, you know what the element is. So this is an advantage. Whatever the language, whatever the country, you know what element they are referring to when they use the symbol of element. Is that okay, students? So I am sure you also wrote answers similar to this in your own words. As long as you give the correct meaning, that is fine. So with that, I will move on to the next question. Extra question 3. Write the symbols of the elements given below. So very easy, we have discussed these before also. First element is hydrogen. So the symbol is capital H. Then zinc, you can remember, that is ZN. Oxygen, what is the symbol? Capital O. Then silicon, you can remember, is Si. Then sulfur, S, just one letter. Then phosphorus, can you all remember? That is capital P. Then carbon, what is the element? It is capital C. And argon is AR. So did you all write all these correctly, students? Hydrogen H, zinc Zn, oxygen O, silicon Si, sulfur S, phosphorus P, carbon C and argon Ar. Those are the symbols of elements that are given here. So with that, I will move on to the next question. Extra question 4. Matter is made of constituent particles. Write the symbols of the molecules given below. So you are supposed to write the symbols of the molecules. Oxygen, you can remember it's a diatomic molecule. So O2. Then hydrogen, what is it? Again diatomic molecule, H2. Nitrogen, N2, because that's also diatomic molecule. Fluorine, you can remember, symbol is capital F, so it's F2. And chlorine, you know, is Cl2. Cl is the symbol and the molecule is Cl2. So oxygen O2, hydrogen H2, nitrogen N2, fluorine F2 and chlorine Cl2. The above molecules are composed of atoms of the same element. So you can understand that here. Oxygen O2, hydrogen H2, N2, F2, Cl2. Atoms of the same type. So what is the name given to such molecules? What are they? They are homoatomic molecules. Homoatomic molecules. So that is the name given to all these molecules. I am sure you were also able to write all these. Then with that, the next question. Extra question 5. Atoms are made of subatomic particles. Write the names of the subatomic particles. So what are the subatomic particles? protons, neutrons and electrons. So here you have to write the names. Protons, neutrons and electrons. Those are the subatomic particles. Then the second one. What are the subatomic particles present inside the nucleus of an atom? What are the subatomic particles? Protons and neutrons. They are present inside the nucleus. So here protons and neutrons. Then the next question. What is the lightest subatomic particle that moves around the nucleus? So you all know electrons are the lightest particles because compared to protons and neutrons, their mass is very, very less, 1 over 1840. So that means they are the lightest subatomic particles, and also you all know they move around the nucleus in the space. So that is electrons. Electrons. Okay, students. So we have written the names of the subatomic particles, protons, neutrons and electrons. Then the subatomic particles present inside the nucleus, protons and neutrons. And the lightest subatomic particle that moves around the nucleus is electrons. So with that, we will move on to the next question, extra question 6. So here you need to complete the following table. So as you can see, in the first row, they have given the subatomic particles, protons, neutrons and electrons. And here, first one is to fill up location, then the mass relative to proton and the charge relative to proton. So then, if we fill up the spaces there, location, protons are present in the nucleus. Where do you get the neutrons? That is also in the nucleus. In the nucleus. Then how about electrons? Space around the nucleus. So here we can say space around the nucleus. Then if we take the mass relative to proton. So proton anyway has a mass of 1. And how about neutrons? They also have a mass of 1, equal to the mass of protons. So here again mass 1. And electrons, it's given to you 1 over 1840. So then we have the charge. Relative to proton, anyway you know the charge of proton, it's plus 1. So neutrons are neutral, that is why the name neutrons. And then electrons, what is the charge? Negative 1 or minus 1. So is this okay, students? We have filled up the properties. So location of neutron is in the nucleus and electrons, they move around in the space around the nucleus. Then mass, protons and neutrons have 1 each, but the electrons it's given to you. And charge, protons have positive charge and electrons have negative charge. Is that clear to you all? So with that, students, I am going to end this particular chapter, and in the next chapter I will be continuing with some more extra questions.